Good morning, class.
Good morning, sir.
Alright, this morning we are going to be taking an example under trigonometry. Last class we started with trigonometry, and this morning I want us to prove this identity. We want to prove that this is the same thing as this. And remember what we did last time? We have defined trigonometry. We stated the basic ratios under trigonometry, the identities, and their reciprocals. You still remember them?
Yes, sir.
So how many ratios we have? Three. So what are those ratios?
Sine square theta plus cos square theta is equal to 1.
Very good. So we have sine, cosine, and what? Tangent. And we have three basic identity, right? So what are those identities? That sine squared theta plus cos squared theta is what? 1 plus tan squared theta is what? Sec squared theta. And 1 plus cot squared theta is what? So we are going to depend on that and prove this. So to start, we're going to use the idea of rationalization to do this. I'll be proving from left-hand side to right-hand side. Some people can prove from right-hand side to left-hand side. I can equally do that. But let's start from left-hand side to right-hand side. So solution now. So from left-hand side, what we have on the left-hand side is this. That is 1 minus cos theta over 1 plus cos theta. So the way I'm going to do this is to change the sign of the denominator. If it were to be solved, we call it conjugate. So I will change the sign of the denominator and multiply it by this. So that will be 1 minus cos theta over 1 minus cos theta. So 1 minus cos theta over 1 minus cos theta is 1. So I did not change anything. I'm just multiplying by 1 in order to get what I want to get. Are we good?
Yes,
so if I'm to multiply, this will multiply this will multiply this. So for the numerator, we have 1 minus cos theta times 1 minus cos theta. Is that good?
Yes, sir.
Then for the denominator, you can see that we have difference of two squares. We have plus here, we have minus here. We have 1, we have cos theta, cos theta. So it's just like if we have something like this, x minus y, x plus. So this is called difference of two squares. The expansion of this will result to x squared minus what? Y squared. So if you expand it as x times x, x squared, x times y, xy, this times this minus xy plus y. You see that this will clear off this. Oh, minus y squared. This will clear off this. Then you have x squared minus y. That's difference of what? Two squares. So that's what we are going to apply here. This and this are difference of two squares. So to expand this, hello Ara. So you expand this, we have 1 minus what? Cos squared theta. Are we good?
Yes.
Any problem with this?
No.
So moving on, if we expand this is a perfect square. But let's expand. That would be 1 times 1, right?
Yes.
That's 1. 1 times minus cos theta will give us what?
Minus cos theta.
Very good. Minus cos theta. Then minus cos theta times 1 will give us what? Minus cos theta. Minus cos theta times minus cos theta will give us what?
Plus cos
That's
theta.
plus cos squared theta. Are we good? Over what? 1 minus cos squared theta. Moving on with that. Now if you look at this, look at the denominator, you should recall back your three identities. The first one, if you recall that sine squared theta plus cosine squared theta is what?
1.
Is what?
1.
Very good. That means I can simply state that sine squared theta is 1 minus what? Cos squared theta. Is that good?
Yes.
So I can replace this with this here. Is that correct? I can replace the whole of this with this. So I will have 1 minus, now look at this. Minus cos theta will result to what?
Minus 2 cos.
Very good. It's just like saying minus 1 minus 1. So we have for the numerator 1 minus 2 cos theta. Then plus cos squared theta. Everything over what? Everything over what?
Sine squared
Very
theta.
good. Sine squared. Because we have replaced this with sine squared theta. Are we good?
Yes.
Look at where we are going to. We want to obtain something like this. So what do you think we are going to do here? Anybody? Okay, what will be Joshua?
We are going to separate the numerator and put sine squared theta.
Very good, very good. Now, if you can quickly recall how to add fraction, if you have 2 over 3 plus 5 over 3, for instance, what will you do? You find LCM. So the LCM is what? 3, right? Then
Yes.
3 divided by this, you know how to do that. Right? So that means I can move from here to here, only move from here to here, right?
Yes.
Based on what I want to obtain. And that is what Joshua has rightly stated. So that is what we are going to do here. So this becomes 1 over sine squared theta minus 2 cos theta over sine squared theta. Are we good?
Yes.
Plus cos squared theta over what? Sine squared theta. Now, I think we are getting something closer to this. Since we have cosec theta there, this can give us what? This will give us what?
Cosec.
Because 1 divided by sine squared theta is what? Cosec theta. So this will be cosec squared theta because of this square. Now, this will give us what? Who can tell us?
2 cosec.
Two cos.
Let's give you on top.
2 cosec cos theta.
2 cosec cos theta.
Yeah.
Very good. How did he get that? This can be separated as 2 cos theta over sine theta because you have sine squared theta. That's sine theta times sine theta. Alright. You're not paying attention. So times 1 over sine theta, right?
Yes.
Do you understand what I did here?
Yes, sir.
This sine squared theta is sine theta times sine theta. Then plus, so Ara, what will this one give us? Ara, quickly stand up. Cos squared theta divided by sine squared theta. You're not paying attention. Eh? Is it tan theta? Okay, who can help us? Who can help us sit down? Okay,
Cos squared theta.
wisdom, thank you. That is cos squared theta. Because cos theta is what? Cos over sine. So that would be cos squared theta. Are we good? Tope?
Yes.
Are we good?
Yes, sir.
So we have cosec squared theta minus Tope, what will cos theta over sine theta give us?
Sir,
Cos theta over sine theta. Is there squared yet? Very good. So that would be 2 cos theta times 1 over sine theta is what?
cosec.
Cosec what?
So,
Cosec theta. Thank you very much, Tope. This will be 2 cos theta cosec what? Theta. Then plus what? Cos squared theta. Are we good now?
Yes.
I think we are closer to this. So who can tell me what I can do to obtain that? Huh? I can do what? Can you see that there is 1 here, but I'm not seeing anything like 1 here. And we have 2 cos theta. If I factor out 2 cos theta, so who can tell me? I think there's something you can do. Who can do that? Think. Okay, Kamori. Okay, anybody? Anybody? Nobody?
Let's. So I will represent cosec theta with x and represent cos theta with y.
That means you want to factorize. But what we have there. Okay, so what you're going to do? I don't have anything like this here. Cosec squared theta. So I will think of a way to replace this cosec squared theta, right? If you recall, you know that 1 plus cos squared theta is cosec squared theta, right?
Yes,
So that means cos squared theta will be cosec squared theta minus what? 1. Are we good?
Yes.
So I can replace, you don't even need this, right? So I can replace cosec squared theta with 1 plus what? Cos squared theta. Tosin, are we good?
Yes.
Do you understand what we are? So if we replace this with this here, this becomes, hope you can see the block. 1 plus cos squared theta minus what? 2 cos theta cosec theta plus what? Cos squared theta. Are we good?
Yes, sir.
Now look at cos square theta plus cos square theta. Who can tell me the result?
2 cos square.
Very good. So that's 2 cos square theta minus 2 cos theta cosec theta, then plus this one. I think we are getting closer, right?
Yes, sir.
So look at this. Who can tell me what to do? If you know it, raise your hand.
You
Okay,
factor
Gideon.
Cos theta open bracket. Now
Okay, we factor out cos squared. Is it? We factor out cos theta. Because cos theta is common. That's 2 cos theta. We have 2 cos theta out, right?
Yes,
And if
sir.
you factor out, what will it be? This will be 2 cos theta. Remember, all squared divided by cos theta, right?
Yes.
So this will clear out one of it. That means inside there will be what?
cos
That will be cos theta. Are we good?
Yes.
Then minus, then this divided by 2 cos theta will clear out this. We have what? Cosec theta. Plus what? 1. You can see that this is the same thing as the right hand side here, right?
Yes.
So this is the same thing as the right hand side. Therefore, it is what? Proved. QED. Any question? Alright, please like and subscribe. Make sure you share for more videos like this. Thank you.